We've briefly covered tests in previous episodes, but I've never explained them in depth. Today we're going to look at writing unit tests and learn a bit more about ExUnit. Let's get started. Testing is one of the most important tools in a software developer's arsenal. It's also one of the most underused historically, although things seem to be getting a lot better on that front lately. Today we're going to cover what is testing and what is it good for, ExUnit, Elixir's built-in unit testing framework. We'll build an example module via test-driven development, and we'll look at a great feature Elixir provides called doctests. So what is testing good for? Well, people often see testing's value in avoiding regressions, and that's a fantastic reason to test. Tests also allow you to refactor your code without concern that you've accidentally changed behavior in some subtle way. I see an even greater value in testing as the way to plan the code you're going to write. Testing is how I think now, and I find it easiest to build a system by gradually writing and satisfying a series of unit tests. Test-driven development also provides valuable feedback that helps you know when a module in your system is getting too complex. If the tests are getting hard to write, the odds are your code is doing too much. The time between when I learned how to test in Erlang and I built a working chat server was just a few hours. Unit testing is a means of testing just a single unit in your system, and this can be contrasted with an acceptance test, which tests the behavior of a system as a whole and verifies that it satisfies the overarching requirements. Unit tests are focused on a single portion of the system so that a single portion of the system can be verified alone. Let's have a look. Elixir comes with a built-in tool for writing unit tests called ExUnit. You've already seen ExUnit test cases in previous episodes. Let's start a new project and talk through a bit more. We'll look at the auto-generated test. Here we can see a test case that was already created for us. I'll comment out doctest for now. We'll come back to this. The test is fairly self-explanatory. It has the name the truth, and it asserts that 1 plus 1 is equal to 2. Let's talk about assertions. Assert here is a macro provided by ExUnit to describe the intended behavior of your system. What happens when an assertion fails? We'll test that 1 is 2. We'll run the suite, and this test should fail. And we can look at it, and we can see that test 1 is 2, assertion with equal failed. It says the left was 1 and the right was 2. So you can see very clearly what the difference is. If this were more complicated, the red and the green would show the differences. Okay, so the inverse of assert is refute. So we'll refute that 1 is 2, and that test passes. These two macros provide most of what you'll need to write your tests. There are a few other assertions provided, and you can check them out in ExUnit's assertions documentation, which I've linked to. To get comfortable testing in Elixir, we're going to create a module of our own using test-driven development, or TDD. If you're unfamiliar with the concept, it's basically the idea that you write your tests first, and then you write just enough code to make them pass and no more. That is, you let the tests drive the development of your code base. We're going to test drive our schizo module. It's going to provide two functions, uppercase and unvowel. These functions will uppercase every other word and remove the vowels from every other word, respectively. Since we'll be using TDD, we'll start with the tests. Let's define some behavior for our first function, uppercase. So we'll get rid of the existing tests, and we'll test uppercase doesn't change the first word. So we'll assert that when we call schizo.uppercase on foo, it's just foo. Next, we'll test that uppercase converts the second word to uppercase. And then finally, we'll add a third test that says uppercase converts every other word to uppercase. So this is enough for now. Let's just start implementing, making tests pass one by one as we go. We'll start by making the uppercase function. So we'll open up lib.schizo, get rid of the auto-generated bit, and we'll define uppercase. It takes a string. Our first test says that it doesn't change the first word, so we'll make the simplest thing that will work. So we'll just return what we're passed. If we run the test now, we can see we had 3 tests but 2 failures, so the first test passed. Now we can move on to the second test case, and the second word should be uppercased. What we'll do is we'll split the input string on space, and we'll uppercase every item in the list to start, and we'll join it back together with a space. So this is not going to work, but this is a step. So we'll come back here. We'll take the string, we'll pipe it through string.split on space. We'll pipe that through enum.map, have a function that takes the word, and then calls string.upcase on the word. Oop. And then finally, we'll go through enum.join. Okay, we can run the tests, and they fail, but if we look, they fail slightly differently, right? Now we're uppercasing everything. Here we're using enum.map to map each item in our list through a function. We really only want to map every other word, and there's sort of a function for this. There's enum.mapevery, so let's try to use that instead. So we can map every, and you can say every how many, so every 2 words, and we'll run it, and it almost works. So if we go back, we can see that it's actually uppercasing the inverse of what we want. So this is the opposite of what we want, but it's neat to see that function. We want to map the even word, so we can't use this. We can use another function from enum, though. It's called enum.withindex. So we'll undo. We use enum.withindex, and withindex will convert an enumerable into a list of 2 tuples, where the first element is the data and the second element is the index in the enumerable. And then we can apply our function to every other word. So we'll go through enum.withindex, so we end up with a list of 2 tuples. And now when we map, we'll be getting a 2 tuple. The first is the word and the second is the index. So we'll pattern match those out. And here we'll say, let me break this up a little bit. Here we'll say if we're even, then return the word. Otherwise, return string.uppercase on the word. And then we join, and if we run the test now, they pass. So with that, we've implemented uppercase. So now let's implement unvowel. First, we'll write some tests, and I will copy and paste them because they're going to be very similar. Change all of the cases of uppercase to unvowel. And unvowel removes the second word's vowels, and it removes every other word's vowels. And then we'll fix these. So it's foo, foobar, foo, br. And foo, bar, baz, hui would be foo, br, baz, wh. So once again, we can run the tests, and of course there's no unvowel function, so we'll go ahead and create an unvowel function. And we'll start off like we did before, just taking the string and returning it. We find ourselves in the same situation as before for the most part, right? We know we're doing something with every other word, so we'll just paste this bit down here and change the bits that matter. So instead of string.uppercase, we will use regex.replace. We'll replace the regular expression that just has A-E-I-O-U with nothing, and then that should work. So let's run the tests, and they all pass. So we're done, right? Not quite. TDD consists of red, green, refactor. So far we've just done red, green. So we've made tests that failed and we made them pass. There's a lot of duplication here though, and removing it will teach us some fun stuff about Elixir. So let's go ahead and refactor this until we're happy with it. The whole point of the test is that now we can do this without fear. We'll start by adding a new function every other word, and it's going to take a string and a function to perform on every other word. And we'll just use it on uppercase to start. So we'll say every other word, we want to do something with this string. Well, let's say string, pipe it through every other word, and we want to do something. So let's go ahead and pull this down to that function, and we can see pretty clearly what needs to happen here, right? So the function needs to get called on the word here. And so then we'll just pass in a function that works. So we'll pass in a function, it takes a word, and then just calls string.uppercase on the word. And then we can do the same thing for unvowel. Well, let's go ahead and run this test first. And it works. Okay, so let's do the same thing to unvowel, where our function is going to be that regex replace, and I'll break it onto a separate line. We can run the tests, and they pass, so this is already a little bit nicer, and it works. So there's still a bit we could do to clean it up. Elixir provides an operator, the ampersand, that makes it a bit easier to produce anonymous functions from existing functions. So we'll use that to extract string.uppercase to see how it works. Here you can see we've made a function that basically just calls string.uppercase. And so if we could just use string.uppercase here, it'd be nice. So we can use ampersand to extract string.uppercase1. And that works. So that's how ampersand works. It just gives you an anonymous function that does what that function did. And then we can use a pipe to make this read nicer. We've already done that. So originally, without the pipe, it would look like this, but I went ahead and did that. Anyway, so this is nice. So we can't just extract regex.replace because it doesn't take a single string argument. So we can't just do that. Instead, we have a few options. We could produce an anonymous function with ampersand and pass numbered arguments into it. And this is kind of weird, but I'll show it to you. It's not weird, it just maybe is not so straightforward. So we'll say the first argument goes here in this anonymous function we just extracted. And I need to actually, sorry, this fn word needs to go. Okay, so this may not be very clear. Let me back this up. So here we're saying we want to extract a regex.replace. We want to go ahead and fill in the first argument, and then we'll take whatever argument we're passed and put it in the second spot in regex.replace. So this is just making that function that we created before. But if you don't love the way this looks, I'm fine with it if people that I'm working with understand Elixir pretty well. And these days it's pretty much everyone that's been working with it for a while. But even still, you might find it nicer to have code that reads like this. So if we just comment that out, and if we said every other word, just remove the vowels, has the nice benefit that it's clear what you're doing without having to read through and figure out what it does. And so if we want to do that, then you can just make a remove vowels function that takes a word and just calls regex.replace. So this is the sort of the innards of what we had before, just extracted to its own function. And now it passes, and if you read the code, it's pretty clear, right? You take the string and then every other word you uppercase, or you take the string and then every other word you remove the vowels. I think it reads really nicely. So either of those last two approaches is acceptable. I think the second is a bit more self-documenting, and that might be nicer to people that are reading your code later. I think it's a good idea to optimize code for easy reading, since you're going to spend a lot more time reading code than you do writing it. At any rate, now we're left with something quite nice looking, and it's very easy to extend it with more functions along the same lines. We just need to define the transformation functions, and we're basically done. Elixir also ships with support for something called doctests. Basically, the way this works is you place an example IEX session in your module or your function documentation, and then you can easily verify its behavior by specifying a doctext test in your test case. So this was cribbed from Python, but coming from Ruby, I never had a chance to play with it before I started playing with Elixir, and I think it's amazing. So let's go ahead and add a doc test to the Schizo module so you can see how it works, and you can also see how to document a module here. So we have module doc, and we'll put a here doc here, and then we'll write some documentation. So this is a module that provides odd behavior for transforming every other word in a string. We can say here are some examples, and then I'll tab in a little bit and do an IEX session, right? So schizo.uppercase, this is an example, and then I can show the return value, which would be this is an example. I can do the same thing for unvowel. It would be this is an example. And then, so now we've defined this, so this is defined in our documentation, but to add them to your test suite, you just want to open up the test module, and we'll add back the line that was removed originally. So this is doctest schizo. If you just add that, now when we run the tests, we can see rather than the 6 tests that we defined, we've ran 8 tests. So we ran the 2 IEX sessions as their own tests. And if they failed, which we'll do, we'll come in here and we'll say, make this fail. We'll run the tests. And now we've got a failure inside of our documentation test. So that's really nice. Now you don't have to deal with documentation that's subtly incorrect. If someone writes doc tests and their test pass, then their documentation is accurate. Today we learned how to write unit tests, test drive a module from the ground up, and we explored doc tests. Armed with the ability to test drive your code, you should be able to level up in Elixir substantially faster from here on out. See you soon!